Volcanoes are some of the world's most fascinating natural structures. In height, size, and energy, volcanoes have been revered by humans as one of the most powerful forces on Earth. But how do they form, and what pros and cons come from the formation of volcanoes and their impact on the world? Volcanoes are one of the factors in the regeneration of Earth's crust, and hotspots are one powerful building block to their formation and the formation of new land. Although islands and volcanoes can be a result of the plate tectonic processes, hotspots are puzzling areas of volcanism that can also explain these land formations. Mantle plumes are columns of hot material rising from the mantle core boundary, through the mantle and into the lithosphere. Hotspots are formed when the plume produces magma from the hot material, breaches the lithosphere, and pours basalt magma into the continental crust or oceanic floor. The mantle plumes or hotspots are stationary, localized areas of volcanism on the surface of the Earth, as you can see in Figure 2a. The rising mantle plume is seen in Figure 2a, Example A, and the hotspot forms in Figure 2a, Example B. Hotspots may occur on land, but when they occur on the seabed, volcanoes can form beneath the ocean as the magma cools and solidifies, creating lava. They can also occur on plate boundaries or within the plate itself, making this formation unique. Due to the stability of the hotspot and how they stay in the same locations, some geologists speculate the plumes arise from deep within the mantle, under the plates. There are multiple recorded hotspots around the world, including the Tasman, Easter Island, Galapagos, Canary Islands, St. Helena hotspots, and they're all formed away from plate boundaries. How do hotspots create volcanoes and islands? Volcanoes can form beneath the ocean as the magma cools and solidifies, creating lava. This process gradually builds layers of material until it breaks the surface of the ocean, creating a small island volcano. Hawaii's 8 tropical islands are some of the youngest land masses on Earth. Kohala was the first island to grow out of the ocean due to hotspots, and over time the volcanoes Mauna Kea, Mauna Loa, Hawaii, and Kilauea formed over millions of years and slowly built Hawaii. The big island of Hawaii, above the surface of the ocean, is about the size of the state of Connecticut. But below the surface, the island is twice the size of Mount Everest, with a mass capable of fitting Everest inside 140 times. The Kilauea volcano has been erupting continuously since 1983. This continuous flow of lava has created over 500 new acres of landmass on the island. Lava moves fast on the Earth's surface at over 2,000 degrees Fahrenheit. Solidifying lava rock on the surface cools slowly, leaving new land behind. How are hotspots and mantle plumes responsible for plate movement? Volcanoes usually occur at plate boundaries where two plates collide, like the Ring of Fire. But Hawaii is over 2,000 miles from the nearest collision boundary. See Figure 4b. So how is it formed? The Hawaiian chain stretches for more than 15,000 miles away from the Ring of Fire in the middle of the Pacific Ocean, atop the Pacific Plate. Oceanic hotspots provide evidence of plate movements due to the volcano formation, leaving somewhat of a hotspot trail. The islands of Hawaii are prime examples of this trail. As the Pacific Plate, or lithosphere, drifts, each volcano drifts with it, away from its mother hotspot, and the volcano becomes inactive due to the loss of its magma pocket. This trail of extinct volcanoes are the visible proof of plate movement. The age of the Hawaiian volcanoes is also obvious evidence to track the movement of the Pacific Plate and which direction it's moving. Kauai, the oldest of the Hawaiian island string, is about 5.1 million years old, whereas Hawaii, the youngest of the islands, is around 400,000 years old and is still growing due to the volcanic activity still seen today. This evidence shows the Pacific Plate slowly drifts northwest and has been for millions of years, or at least since the hotspot has been active. What about continental hotspots? Yellowstone National Park is home to one of the most distinct land-bearing hotspots on Earth. 5 miles below the surface of the Earth lies Yellowstone's volcano. Unlike Hawaii's Kilauea, this volcano is underground and has yet to breach the surface of the Earth. Yellowstone has been the location of numerous volcanoes in the past. Evidence of these volcanoes are preserved due to the presence of calderas. Calderas are craters that collapse atop the volcanoes or magma chambers during their eruption or after due to collapse of surface rock. 15 calderas, due to over 140 eruptions, have been mapped through Yellowstone, creating a caldera trail running southwest to northeast, evidence of Yellowstone hotspots. The North American plate is slowly moving southwest, about 1 inch per year. Geologists can estimate this movement using the size and location of the calderas, much like the islands of Hawaii, and the evidence of previous eruptions. The source of power to Yellowstone hotspot is a magma plume which reaches 450 miles deep and is believed to contain 300 cubic miles of magma, as you can see in Figure 6b. When hotspots occur on land, the breaching lava from the magma chamber, due to cast pressures, creates an explosion, then forming a surface volcano. This is why the Yellowstone volcano is so widely studied. The event that the Yellowstone volcano actually erupts will be the largest volcanic explosion in human history. How are hotspot volcanoes different from island arc volcanoes? The process of subduction takes place at a convergent plate boundary or subduction zone. Here, the ocean floor or oceanic crust is consumed underneath the continental lithosphere, which is made up of continental crust and the mantle lithosphere. Because the oceanic lithosphere is more dense than the continental lithosphere, the subducting slab of oceanic lithosphere into the weak asthenosphere is the main culprit of earthquakes, specifically, for example, those surrounding the Pacific Ring of Fire. Magma, or molten rock, is also generated through subduction and is heated to greater temperatures as it is subducted into the mantle. Magmas produced by subduction also occur in the upper oceanic crust and rise due to its low density and water vapor to fuel volcanoes that eventually build above sea level to form a curve of islands called island arcs or island arc volcanoes, arced due to the curvature of the Earth. This process can also produce volcanoes on the coast of continents called a continental arc. These volcanoes are different from hotspot volcanoes due to subduction formation rather than a hotspot. Subduction volcanoes are also usually active due to the consistency of volcanic activity and rising magma. Volcanoes can also be formed by two plates of continental crust diverging or moving apart, seen in Figure 7b. This also allows magma from below the plates to rise through the cracks to create a mid-ocean ridge. This ridge can continue to grow to form volcanic islands or even multiple. Iceland is unique because it is located on a plate boundary. Dissected by the Mid-Atlantic Ridge, Iceland is constantly being built by the diverging plate boundary and by the Icelandic hotspot below it, both working simultaneously to form new land. At least 62 miles wide and 372 miles deep, the Iceland mantle plume is one of the largest in the world. Created 50 million years ago, this plume is still active today. Iceland is a distinctive site for volcanologists and geologists because of the rate that magma is produced there. As the Mid-Atlantic Ridge diverges, decompression of the underlying material occurs. This creates melting of the material into magma. While this occurs, the hotspot is transferring heat from the mantle to the surface of the Earth, simultaneously melting the material and creating an immense amount of magma unique to Iceland. Although volcanic activity is key to knowing how the Earth's continents and islands were and are being formed, volcanic activity and volcanic explosions are extremely hazardous to human life. Toxic gases, ash, and mudslides are common hazards associated with volcanic eruptions. These hazards impose health and economic risks. Lava flows and earthquakes are also common due to the amount of magma moving to the surface due to hotspots. Volcanoes are one of the most destructive forces on Earth, but they are also one of the most constructive. While tropical islands are still volcanically active, fringing reefs form around the island. Once the island is extinct due to volcanic activity, the volcano subsides and is weathered down. This allows the fringing reef to grow, forming a lagoon and barrier reef. As the island weathers below sea level, an atoll is formed around the submerged volcano. These reefs and atolls provide habitat for numerous animal species, as well as provide economic value to its surrounding human communities. Speaking of construction, excitingly, a new Hawaiian island is being created. The hotspot that created the chain we know today is located 20 miles south from the main island. Liohi is a new underwater volcano being formed, and it is already 2 miles above the seafloor. As the lava is weathered by water and wind, it becomes soil in just around 100 years. Volcanic soil is some of the most nutrient-rich soil in the world. Newer volcanic islands start out barren and without life, but spores and seeds deposited by birds and wind sprout new ecosystems. The weathered volcanic ash is easily tilled, percolates water easily, and is nutrient-rich with soluble molecules. This is why Hawaii, Iceland, and Yellowstone are not only some of the most beautiful and dangerous destinations in the world, but they are also symbolic testaments of Earth's power over life and death.